Hello, namaste, dear Sathi students. I am Priyanka Rajeev from Department of Mechanical Engineering, IIT Kanpur, and this is lecture 8 of Laws of Motion, Physics class 11th. And today we will be seeing more problems of pulley block problems model. So I'm trying to introduce you to different models of this problem. Okay. So last class we have learned that for a system of pulley like this, if you take the masses to be like m1 and m2, then the acceleration of the system will be m1 minus m2 by m1 plus m2 times g. Right. So why I was saying taking m1 is because I am assuming this acceleration to be in this direction. If m1 is lesser than m2, you will be getting a negative quantity over here, which will indicate that m2 is larger than m1, and the acceleration is in the other way than the assumed direction. So here, in this problem that is given here, you are asked to find the tension, acceleration of the system, and find acceleration of the system and tension in the string. Okay. So you're supposed to find the acceleration of the system and tension in the string. Obviously, you know that 2m is larger than m. So if you're hanging two blocks like this acceleration should be the whole system will be falling downwards via the right side. So this will go like this, and m will go upwards with an acceleration a, and 2m will come down with an acceleration a. Assume that the tension in the string is like this. Okay. Tension is always acting away from the block that is hanging, so that is how it is. So since the string is there is only one string over here in the system, tension along the string will be constant, and that we are taking it as T. We are assuming a massless string here. And this is an ideal pulley, so again, friction is not there, and the mass of the pulley is not taken into consideration. So from the direct result that we have learned from the last class, I can write the acceleration of the system as it is like m2. If I take m1 minus m2 by m1 plus m2 times g, I can substitute m1 as 2m, m2 as m, and again 2m plus m times g, which is equal to mg by 3m, that is equal to g by 3. Okay, so that is the acceleration here. Now for the tension, again we have learned the same equation. What was there? This is from the direct formula that we have learned from the last class. So that's why I'm not deriving it all over again. I am showing you how to use this result from the last class to solve this problem. Okay. So this is kind of like a revision for the equations that we have derived from the last class. So this is tension as 2m1 m2g by m1 plus m2. Again, m1 here I am taking it as 2m. So 2 times 2m times m divided by m1 plus m2 is what? 2m plus m. So that gives you 4m squared by 3m, right? 3m. That will give you 4 by 3m. So that is the tension. Sorry, a g is also here. G here, g here, so g here. So now it becomes 4 by 3 mg newtons. Okay. So that is how you find the tension in the string. Now, another question. So this is a bit more complicated system, right? Instead of 2 blocks here, you are getting 3 blocks over here. And it is given that m3 plus m2 is greater than m1. So this side mass is higher than this one. So that means acceleration will be like this, right? You can assume the acceleration like this. And even if your assumption is wrong, what will happen? You will be getting a negative sign over here, and you can just understand that the acceleration is opposite to what you have assumed. Again, you need to find the acceleration of the system, and then you need to find the tension in the string also. So how to do this? So first of all, we need to understand what is happening in the system. Okay. So there is this block is there hanging, and what will happen if a block is suspended like this? There will be weight acting. Because of this weight, there will be tension force acting to hold this weight upwards, or something might be happening because of the string is attached. Either it will stay in equilibrium or it will go upwards. Since here this m3 plus m2 is greater than m1 is given, you know that this will be this tension will pull this block upwards with an acceleration a. Okay. And what will happen here in the string? Again, there is a tension force. The same tension force is here. Okay, that is acting in the string, and this tension force will pull this block upwards again. And okay, so till this you can understand that there is one string going on like this, right? This can be the same string or the different one. We are taking it as a different string, right? Because this string is suspended between m2 and m3, so you are taking this as different. So we have learned that only the tension is constant in the same string. You don't know about the whether the tension in one string is equal to the other one. So you have to take this as T dash. And again, this T dash is holding this mass upwards. And there are other things like M2G, which is acting from the string, from the block downwards. And there is this M3G acting downwards. Right. So this is the free body diagram of this system. So we will be taking it one by one. You can see that there are three unknowns here. One is this T, one is this A, and one is this T dash. Okay. So for solving three unknowns, how many equations you need? You need three equations. And you have got three blocks to draw free body diagram. So I think that from these three blocks, you can derive three free body diagrams and equations from the three free body diagrams. And with these three equations, you can solve the three unknowns, right? So let's solve for the first block. So I'll take this M1 block here. So M1 block, what all are the forces that is acting? One is this M1G, and another one is this T force, right? The tension force. So you can write it as T, and this block is going upwards with an acceleration of A. So what we know is net force equal to mass times acceleration. So net force is T minus M1G. I have taken T as positive because A is acting along T direction, is equal to M1 times A. So that is equation 1. Then there is this another block, that is M2 block over here. So what is happening with M2 block? Downwards, there is this M2G acting, and there is this T dash is acting. Then there is T acting opposite to M2G and T dash. And the whole system is going downwards with an acceleration of A. Right. So what will happen? You can equate all the net forces and equate it to mass times acceleration. So that is M2G plus T dash minus T. equal to m2a. That is equation 2. And again, for block M3, what is happening? M3G is there and G dash is there, and this whole system is acting down, like going downwards with an acceleration of a. So that can be written as M3G minus T dash equal to M3 times a. So that is equation number 3. So equation 1, 2, and 3. So 3 equations, 3 unknowns. How to solve it? You simply add all this together. You'll be getting what? 1 plus 2 plus 3. You'll be getting T minus M1G plus M2G plus T dash minus T plus M3G minus T dash is equal to M1A plus M2A plus M3A. So what all gets cancelled now? You can see that T and this T, they are getting subtracted, and T dash and minus T dash is getting subtracted. Then, so what is left here? You can see that M1G minus M1G plus M2G plus M3G equal to M1A plus M2A plus M3A. So A, you can take it common. So what you will be getting is G and A, you can take it common. So you'll be getting M2 plus M3 minus M1 by M3 plus M2 plus M1 times G equal to A. So that is the acceleration of the system. Okay. And substituting this acceleration, you can get T dash and T. Okay. From this equation, you can, if you substitute this acceleration, you will be getting an expression for T. And from this equation, you will be getting T dash also. If you substitute this equation of A into that, we can see that again. So how you will be doing is T minus M1G equal to M1 times A. So this A equation, you can write it as T equal to M1G plus M1 times M2 plus M3 minus M1. Sorry. M3 minus M1 by M3 plus M2 plus M1 times G. Okay. So this is the expression for A. Okay, similarly, you can get for T dash also. So I hope that you have understood that. Now, for the next problem. So this is a different arrangement of pulley and blocks here. So you usually have seen this vertically, how this tension is acting on a block over a pulley. Now you will be seeing how, when a block is placed on a horizontal surface and there's a pulley and a string arrangement, and how this system acts. Okay. So you're, as usual, we are assuming a smooth surface. So this is the smooth surface over here. Okay. And over the smooth surface, block M1, block of mass M1 is placed. And there's this block of mass M2 suspended using a string over a pulley. So what will happen? You know that this will try to go downwards with an acceleration of A due to its weight. And because of this acceleration, this string here will also move with an acceleration of A. Right. And obviously there will be tension over the string. So that is here like this. This is T. And for this block M1 over here, this is weight acting downwards, M1G. And because of this weight acting on the surface will provide a normal reaction perpendicular to the contact. So this is what is happening over here. So here also there is this tension. Okay. So again, you have to draw what? This free body diagram of M2. So M2, what will happen? M2G is acting downwards, T is acting upwards, and A is like the acceleration of this M2 downwards. Net force equal to mass times acceleration. So M2G minus T equal to M2 times A. So that is one equation, right? Then you have the free body diagram of mass M1. So that is like what? You have this M1G acting like this. Then there's this horizontal force that is T acting here. And there is this vertical N acting here. And this whole system is going rightwards with an acceleration A. So vertically, there is no movement that is happening, right? So what will happen? M1G is equal to N. So that is sorted. This is like vertical. Okay. Horizontally, what is happening? Because of this T, the T is the only net force that is in the horizontal direction, right? So T is accelerating the system, this block M1 with an acceleration of A. So that is horizontal. So I'll take this as equation 2. So T equal to M1A. So we got that, right? So T equal to M1A. Substituting this equation 2 in 1, you will be getting what? M2G minus M1 times A equal to M2 times A. Right. So you'll be getting what? M2G equal to M2 plus M1 times A. So A equal to M2 by M2 plus M1 times G. Okay. So you can understand that this whole M2 and M1 is acting like the kind of like, see, this M2G is the force here, right? This is the only driving force here. You can intuitively imagine that it's like instead of this M2 block over here, if you are pulling that string with a force which is equal to M2G also, the same effect is happening, right? So that is that external force being provided to that system. So initially, if there is this, there was no M2 over here, or there was nobody pulling the string, what will happen? The string will be khali over here. So there is no force over here. So this block is simply staying on the surface of the smooth surface. So that will be at equilibrium, right? So when you're suspending this M2, what is happening? There's this, due to the weight of the block, this string is pulled downwards. And because of that pulling of that string, this M1 is also moving, right? So this is like M2G. This is equivalent to M2G being the F external force, and M2 plus M1 is this external force has to pull both M2 and M1 as one system. You understand? So that is what is happening in the system. So this is kind of like equivalent to F external pulling M2 plus M1 combined. So that is what we are seeing here in the acceleration expression, right? And substituting this acceleration, you can get T. So what is T here? T equal to, from equation 2, T equal to M1 times A, that is equal to M1 M2 by M2 plus M1 G, right? So that is tension over here. Now, next question. So this is again a bit more, one more addition to this setup is this block over here, right? And two pulleys are there. When you are seeing this kind of question, what you have to do is you have to understand that between two blocks, the tension in the string remains constant, right? So you are taking this as one string and this as another string. Okay, that is the first thing in your mind. So there is this two strings and three blocks. Okay, this 1, 2, and 3. 3 blocks are there. So you will be getting 3 free body diagrams, and the whole system is connected. So the acceleration is going to be the same. If it is going this way, and this is going downwards with an acceleration A, this block is going to go with an acceleration A towards the right, and this block is going to go upwards with an acceleration A. Okay. So these are the few trivia that should come into your mind when you are seeing such a system. So what I have told you is this, you're taking it as one string. So we will start from here. Okay, so this heaviest mass over here is 2m. So I am taking this as 2mg is the weight, and because of this weight there is this tension over here, and this tension is going to pull the string like this, and here also this tension will act to pull this block M, right? So this is a tension force acting throughout the string 1. Okay. Then here again there is this block M. So this mass will be, weight will be acting downwards. That is mg. This normal reaction force will be provided by the surface to the block. And again, what will happen? So this whole system is going downwards with an acceleration A, right? So I'll use another color. So this whole thing is going downwards with an acceleration A. So this string will also accelerate with acceleration A. So this block will also move towards right with an acceleration A. Again, the string over here towards the right of this block M, what is happening? This is also being pulled, but again, the tension here is going to be T dash. Okay, this T dash is going to pull the string here also. So this T dash is going to pull this block upwards with an acceleration A, right? And there is this weight of this block acting mg, right? So this is what is happening. Now to solve this thing, we will draw 3 free body diagrams, derive 3 equations, and then solve them simultaneously to get the 3 unknown values. So what are the unknown values here? T dash, T, and A. We need to find these 3 unknowns. So we need 3 equations. We'll start with this block 2m over here. So 2m has this 2mg acting downwards, T acting upwards, and this whole system is accelerating downwards with acceleration A. So you will be writing this as net force equals mass times acceleration. So net force is T minus 2mg equal to 2m times A. That is equation 1. Then you have another block. So this is the second block over here. This first block, and this is the third block. So this is first block over here. Then second block is this M. So M has this mg acting downwards and normal reaction acting upwards. And this tension force T, which is acting towards the right, and T dash acting towards the left. And the whole system is accelerating towards the right with acceleration A. So vertically, what is happening? Mg equals n. So that is vertical. And horizontal, what is happening? Since A is along T, I'm considering T as the larger force over here. So T minus T dash equal to M times A. So I'll take this as equation 2. This is horizontal. Okay. So what is happening? T minus T dash. So in the previous question, it was like T equal to M1G, M1A, right? Because there was no force here. Now we are getting another thing, one more extra force towards the left side. So we have to equate it like this. Okay, here I think I have done a small mistake. What I was supposed to take it as 2 mg minus t. Why is that so? Because the acceleration is acting downwards. So 2 mg is a larger force over here and t is a smaller force. So I have to, even if I'm taking it the other way, I'll be getting acceleration in the negatives with the negative sign. That's the only mistake. Okay. Anyway, just to avoid confusions, I'm just taking it like this. And so from the second free body diagram, we have got T minus T dash equal to M times A. And the third free body diagram we are drawing, that is going to be this one, right? This one. So mg is there and T dash is acting upwards. And this whole system, whole block is accelerating upwards with an acceleration of A. Again, how to write the equation? Net force, that is T dash minus mg, because A is along T dash, equal to M times A. That is equation 3. Now, equations 3 unknown. How to solve this? Just, you will add these 3 equations first. So what will you get? 1 plus 2 plus 3 will give you. So RHS is what? 2 mg. I'll use a different color. 2 mg minus t. So that is RHS over here. Here, second equation is plus t minus t dash plus third equation, just t dash minus mg equal to LHS is 2ma. Then second equation LHS is ma, and third equation LHS is ma. Now, what all things will cancel out? So this minus t and this plus t will cancel. This minus t dash and plus t dash will cancel. Now you have 2 mg and mg. So that will be 2 mg minus mg is mg equal to 2 ma plus ma plus ma. So 3 ma plus 4 ma. So A equal to m and m will cancel out, g by 4. Right. So this is the acceleration of the system. Now, if you substitute this acceleration in equation 3, you will be getting t dash. And if you substitute this acceleration in equation 1, you will be getting t. Okay. Now, another type of problem is this pulley on an inclined plane. So what will happen when you are suspending 2 blocks over a pulley over an inclined plane? Again, we will solve it for a general case. So I am taking this as theta. So theta here is a inclination of this inclined surface. I am assuming this inclined surface to be smooth. Okay, so this is mass m1 and this is mass m2. So over a smooth surface, this block is placed, like the block mass of mass m1 is placed. And with intuition, you know that this m2 is will be having a weight downwards, which is m2g. Because of this weight, this block will be moving downwards with an acceleration of a, and this whole thing will provide a tension in the string. Tension in this string, which is T. So T tension will be there throughout the string, right? And this M1 again will have this M1G acting downwards, and there will be this normal reaction from this surface. Okay, this is the normal direction. So that is this N. So you have to again do what? Like resolve this M1G into two components, which is like one is vertical or perpendicular to the surface and one is parallel to the surface. So this will be, I'll draw it over here. So this is our M1, sorry. Wait. So this is our M1G. This is the inclined surface. Okay. This is the perpendicular to this surface. So along this perpendicular to the surface, what will happen? This is M1G, right? M1G. So along the perpendicular to the surface and along the parallel direction of the surface, there will be two components. Okay, if this is 30 degree, then this is 30 degree. So this is M1G cos 30. So here we are taking it as theta, right? So I will take it as theta over here. So this is theta, and this is M1G sine theta. Okay, now you need to draw these components over here. So this is M1G sine theta, and this is M1. Okay, M1G cos theta. Okay, now we are all set to draw free body diagrams. So there is this one tension over here and one acceleration is there. Two unknowns. We need two equations to solve two unknowns. So to get those two unknowns, two equations, we will be using two free body diagrams. What are those free body diagrams? One is of M2. M2 is doing what? So this is M2, right? This is M2. So M2 has this M2G acting downwards and T acting upwards, and the acceleration of this block is A towards downwards. Since A is downwards and M2G is downwards, that means M2G minus T equal to M2 times A. That is equation 1. And for the block M1, I'm drawing it straight. Okay. If you want, you can draw it in the same inclination also. This is like this, right? So this is the inclined plane over here. So there's this M1G cos theta acting perpendicular to the plane, and M1G sine theta acting parallel to the plane, and N is there, and there's this T. Tension is also over here. Now you can easily understand how to equate this, right? So perpendicular to the plane, you will be equating first. Perpendicular to the plane, there is no movement, right? Movement of this block. So it's not going moving in the perpendicular direction of the plane. So that means N equal to m1g cos theta. And parallel to the plane, what is happening? Parallel to the plane, there is this T acting, and this whole system is acting like this, right? It is accelerating upwards along the T direction. So what is happening? T minus m1g sine theta is equal to m1 times A. So this is equation 2 I am taking. Okay. 2 equations, 2 unknowns. What will you do? You can just simply add these 2 equations. You will be getting m2g minus t plus t minus m1g sine theta equal to m2a plus m1a. This t and this t will get cancelled. m2g minus m1g sine theta is equal to m2 plus m1 times a. Now a equal to m2 minus m1 sine theta times g by m2 plus m1. Substituting this t, this a in any equation will give you t. You can substitute it here also, will get t. So every time you have to focus on the fundamentals. So what are the fundamentals? In the same string, tension along the same string is going to be constant. If it is a massless string, I repeat, if it is a massless string, then the tension along the string is going to be constant. Then the second thing is, you have to always know when in an inclined plane or something, you should know to resolve the vector into the components, the respective components, which is along the plane and which is perpendicular to the plane. That is very essential, so that you will you can equate the respective components in the same direction to be equal to 0 if it is in equilibrium, or if it is moving, you can equate it into mass times acceleration. And then third thing is there are these fundamental equations that we have derived earlier. So with that, you can just directly solve the problems. That is one thing. So everywhere we are just using Newton's second law and third law. That's it for these problems. And you should always know how to draw a free body diagram. And depending on the number of unknowns, you will be needing that many number of equations. So you should know how to derive those equations from the free body diagrams that you can get from the diagram given. Okay, so these are the fundamental concepts in solving this kind of problem. Why am I solving this kind of problems? Is because I want to show you the common kind of problems, the possible models of the problems that will be asked in any kind of exams like NEET or JEE or anything of that sort. So that's why I'm giving you some similar models of these questions. Okay, now we will be giving this angle some values, and we will be solving this problem over here. So again, this is a double inclined plane. You can take it as a triangle, right? So that this surface of this plane is smooth, and over the smooth surface 2 blocks are placed. Okay, now what is happening? So these 2 blocks are having equal mass, right? So usually over a pulley, if you are suspending 2 equal masses, what will happen? So I have these 2 m's over here. What will happen? It will be at equilibrium. Why? Because this mg is acting like this mg is acting like this. So tension is like this and tension is like this. So here from equation from free body diagram 1, you'll be getting T T equal to mg, and free body diagram 2 also T equal to mg. So in both the places, the tension is well balancing the weight of the block, so it will remain in equilibrium. You can imagine a balance. So I hope that you know what a balance is. So this is something called balance. It is for measuring the mass of the object, mass of the quantity of anything that is, especially in shops you will be seeing that, right? So this is the balance. So what is happening over here? You will be placing a non-mass over here, and you will be keeping something like rice or anything of that sort over here. And if this is 500 gram, and if this balance is standing at the if it is properly balanced, that means this there will be a needle over here. If that is in this mark, like at the proper mark, you can understand that this is also 500 gram. Okay, if this needle is going in this way or that way, that means it is less or more. Okay, so accordingly you have to take the extra mass from this side or add extra mass from this side to make it proper, so that this side can be equal to this side, so the mass will be equal, right? So that is the concept of balance. Okay, so similarly here, if two equal mass blocks are there suspended off the pulley, it will stay in equilibrium. But what will happen over this inclined plane? What is going to happen? The effect of this M1G over this inclined plane and this inclined plane is going to be different. Why? We have seen when we are resolving, there is this component of mg sine theta acting over here, and here also this is mg sine theta is acting, right? So the sine theta is going to play a greater role in determining whether this is going to be this whole block is going to stay in equilibrium or move towards left or right. Okay, so you know that sine of an angle is going to increase when you go from 0 to 90 degree. Sine 53 is will be larger than sine 37. So the effect of this mg in this side of the plane, this right side of the plane, is going to be larger than the LHS. So what is going to happen? This mass is going to go downwards with an acceleration of A. Okay. These are the intuitions that you will be getting once you are seeing the problem. So with this similar equation, what will happen? This angle is going to increase, and it will be 90 degree. Okay. So at 90 degree, what is going to happen? The sine theta will be sine 90, which is equal to 1. So that is what will give you mg over here, right? Or if it is going like this to this side, and sine 90, sine 80, sine 70, like that, if it goes to sine 0, what will happen? Sine 0 is 0. So this tension won't be there, because it will be like a block is placed over a smooth surface, like horizontal plane. So again, it won't move, right? So these are the extreme cases that we have seen already. Now we will solve the problem. So how to solve this? Okay. Now we have got a plain canvas. Let's solve this problem. So this is 37 degree and this is 53 degree. Two masses are being suspended over the smooth surface of this double inclined plane. So we know that the weight of this block is acting downwards. This is mg, and this is also mg, and this can be resolved into m1, sorry, okay, mg sine theta. So here theta equal to 37. So I am writing it over there. And this is mg cos 37. Again, here this side also you can draw a perpendicular component perpendicular to the surface, that component, and parallel also you can draw. So what is happening over here? This is mg sine 53 and this is mg cos 53 degree. And due to this mg sine 53 degree, what will happen? There will be a tension force that is acting along the string. And here also this tension force will be there. This will be balancing the mg sine 37 here. Balancing in the sense like the whole system, I'm assuming that it will move downwards in this side, okay, in this direction. So I have taken it like that. Even if you're assuming it in the opposite direction, there is no problem, because what will happen? Once you're solving, the end result will be having a negative sign. So that gives you the idea that whatever you have assumed, the direction for the acceleration, that is wrong. Okay. So what is going to happen? You can draw a free body diagram of both this blocks. So this is one block M. If you want, I can draw it in the inclined plane itself. So this is the block M. This is mg sine 37 degree. And this is T. And this mg cos 37 and normal reaction, they will balance out each other. Why? Because there is no external, there's no movement of this block along the vertical or the perpendicular direction of the plane. So you can equate this as okay, so the acceleration, I have taken it in this direction. So from free body diagram 1, you can write it as T minus mg sine 37 degree is equal to ma, that is equation 1. In the vertical direction, you can simply write it as mg cos 37 is equal to n. Okay. Then there is this another block is over here. So that also I am drawing it in the inclined plane. So this will be like mg sine 53 is there. So here there is this T is acting, and there is this normal force and this weight component which is perpendicular to the inclined plane. So 53 degree. Okay. Now equating the vertical component, you will be getting n equal to mg cos 53. Okay, I'll do one thing. This is n1 and this is n2. I'll be writing that like that to avoid confusion, because both the normal reactions are not the same. Okay. Now n1 equal to mg cos 53 degree. And the other thing is like there is this acceleration that is take this block is moving with an acceleration a towards the right side. So I'm taking that into consideration. So here net force equal to mg sine 53 degree minus T equal to m times a. This is equation 2. Now to find acceleration, what will you do? Just add equation 1 and equation 2. You will be getting T minus mg sine 37 degree plus mg sine 53 degree minus T equal to ma plus ma. Right. So this T and this T, they are getting subtracted. And I can just divide it by m throughout. So what will you get? G sine 53 degree minus G sine 37 degree equal to 2a. right? Or if you want, you can keep the m, and you will understand that this will cancel out in the next step. So here what will happen, sine 53, I have you know that the value is g times 4 by 5, and 37 is g times 3 by 5, and this is 2 times a. So a equal to what? You can take this 4g minus 3g by 5. So it is g by 5 times 2. So g by 10 is the acceleration. So it's a very small acceleration, right? Compared to what we have, compared to the real g is 10 meter per second square. So it is 1 by 10th of that. It's a very minute acceleration. There will be a minute movement of the block. Okay. So I am concluding my problem, the problems, the pulley block problems over here. And next class, we will continue with a new topic of laws of motion. So that's all for today. Thank you and have a great day.